Hi everyone, I hope you're well. This video is the introduction for Lab 10. In this lab, we'll be computing percentile ranks on birth weights in the NSFG data. Now we're going to see that the birth weight is expressed as pounds and ounces. So we'll have to convert pounds and ounces to a single number, which will be ounces, as we'll see. And some of the pounds and ounces values in the data are invalid. So we're going to see how to do data cleaning. Okay, let's start. All right, so these are the two fields, birth weight in pounds and birth weight in ounces in the NSFG data. So remember, when you use these to access these fields, the values in these fields, in your code, you write item dot and then the field name. Okay, so here's an example. If a baby was born at a birth weight of 8 pounds, 5 ounces, birth weight pound would be 8, birth weight ounces would be 5. Okay. So working with a percentile rank, we need a single number. Right? So we need to convert pounds and ounces to just ounces. And here's the equation to do that. So we take the birth weight in pounds, multiply it by 16 to convert that to ounces, and then add the birth weight in ounces, and we're done. Some of the records, if we actually look at the values for the birth weight in pounds and ounces, we would see these NaN values. That stands for not a number. So it's these values that we need to clean. Looking at the code book for these fields in the NSFG code book, here are the values and their meanings. I don't know why these categories were put here, but the numbers are the actual birth weight in pounds. And these inapplicables are probably where the not a number is coming from. And those are probably for records relating to a pregnancy that resulted in a miscarriage or an abortion. So we want to ignore records with these values in the field, and also records with these values in the field. So the records we want to work with will have birth weight in pound values between 0 and 95. Although I don't think I've ever heard of a baby being born that weighed 95 pounds. Okay, so here's the codebook information on birth weight in ounces. So similarly, we have some inapplicables and also these not ascertained, refused, don't know values that we need to clean. And so at birth weight in ounces, we want to only work with those records where the field value is between 0 and 15. So, as you'll see in the lab overview, we use a nested conditional in order to do the cleaning for both of these. So we have one conditional for the birth weight in pounds, and then beneath that nest a second conditional, an if statement, for birth weight in ounces. You'll see more on that with the lab overview. Okay, so you're going to write a function today that computes percentile rank. So here's the definition. For a given value, the percentage of values in a collection less than or equal to that value. So, an example. Let's say a final exam was given and a score of 75 out of 100 was in the 90th percentile. What that means is that 90% of the exam grades were 75 or less. Think about that for a second. That means that only 10% of the exam grades were greater than 75. That was one difficult exam. Okay, right, so again, a score of 75 is in the 90th percentile. %90 of the grades were 75 or less. Okay, let's move on to a couple Socrative questions. As I had done in the previous lab. I'll introduce the question, explain if necessary, and then you can pause the video, think about your answer, and then resume the video to hear the correct answer and the explanation. Okay. Question 1. You want to clean the birth weight in pound data. Which conditional, or is there nothing that needs to be done? Would you use one of these conditionals or one of these conditions or none of the above? I'll give you a hint. It's not none of the above. I'll pause here. Think about your answer. Okay, the answer is C. We want to work with those birth weights between 0 and 95 inclusive. So that's why we're using less than or equal. Okay. What is the percentile rank of 2? So here are some values that we counted. Right, the value 1 occurred twice, 2 occurred 5 times, etc. There are 20 total items. What is the percentile rank of 2? I'll pause. Okay, the answer is B, 35%. How many values were there that were equal to 2 or less? Well, 5 plus 2, 7, divided by 20, it gives us 0.35, and then multiply that by 100 to get the percentage, 35%. Let's try another one. Same data, but what's the percentile rank of 5 now? I'll pause. The answer is C, 90%. 4 plus 7 plus 5 plus 2 is 18. 18 divided by 20 is 0.9 times 100 gives us 90%. Okay, that's the introduction to the lab. You all take care.